So good morning, everybody. I'd just like to welcome you to this IMS session at the GSE conference today, and hopefully you can hear me loud and clear. So this session is going to be on from IMS legacy to infinity and beyond. And a bit of context to this, it's I think, so it's Dougie Lawson from RSM who's going to do the presentation, and he's been working for many years, over 39, maybe even 40 years.
Well, it's 39, Dominic.
39, okay, yeah. Only 39.
Only 39.
And the session, and the session is going to be on sort of things like IMS catalog, ODBM, Java DLY, JDBC and SQL for IMS. So it's not all of the sexy stuff, but it's certainly I would say some of the newer stuff that some people might not have had a play with yet. So without further ado, I'll hand you over to our very experienced Dougie, who will lead this session. Thank you.
Morning. Right, we've decided we'll do the questions at the end. So if you save up your questions, make notes on your post-it note and ask the questions at the end. And what we're going to talk about is some of that new stuff that's turned up since version 11, version 12. So I've got an agenda slide or two. We're going to talk about where we are today, where we're heading tomorrow, catalog, ODBM, Connect, a little bit of repo, and then some Java programming, and then some ODBM stuff. And I did mention managed ACBs, but there's not a lot I'm going to say about managed ACBs at this point. So what I'm assuming, and this is based on the systems that I've been playing with in the last couple of years, is that we're running version 15 or 1 or 15.2, and we've got the traditional old DBDC system, which some folks like to call TM. We've got mostly HDAM and HIDAM. There's going to be an odd DEDB there. There's going to be maybe a HALDB. If there isn't a HALDB, at the end of the presentation, we're going to have a HALDB. And we're coming at this with no catalog, no ODBM, and any JDBC stuff is only into DB2 at the moment. And any stored procedures, we're using the IMS Connect component. And then because we love Kix, we're going to talk a little bit about Kix and Kix as a DRA. At the end of the presentation, we're going to talk about all those extra bits in the middle, catalog, ODBM, and briefly talk about how that leads us to ZOS Connect. The catalog, new with version 12. I was out in California at the time, and there's a red piece which gives lots of details of how to get it going. I think the red piece is still current. That was written by me and Jeff Nichols. So what we've got with the catalog is, like DB2 has a catalog, as soon as you want to do Java and SQL and JDBC and all that stuff, somebody needs to hold some metadata, which is data that describes your database. It's the stuff we used to keep in the old IMS DBDC data dictionary, but now we're putting it in a database that's actually usable by IMS. So metadata, as I said, is data that describes data, and the catalog is a requirement for Java, for SQL, IMS, and COBOL. And there's some bits and bobs we're going to have to do to get it to sit in our system. So why do we need it? In the old days, when they first started with Java, they decided to put the metadata in a jar file. this did not work. Jar files were relatively easy to create. There was this thing called the DLI model utility, which would map your DVD into a Java object. So you read the DVD, you create a metadata Java file, and then you push that out to every client. When you've got 5 clients, it's easy. When you've got 10 clients, it's easy. When you've got 100 clients, it starts to get difficult. When you've got 1,000 clients, it gets to be impossible because it just does not scale. And your jar file had to match the DVD that was in production. So if you changed the DVD, everybody had to change the jar file. And there was no way to check that the jar file matched the database. So it all got horribly impossible. Some of the jar file and the DLI model utility stuff still exists, but it really is not worth bothering looking at it, except for the archaeologists' point of view, where, you know, is a piece of history. And the Red Book is still there, but again, it's history now. So the catalog, as I said, introduced with version 12, solves the problem of where do you put the metadata, because now the metadata lives on the mainframe. And the first time the Java person connects with their Java application program, he pulls the metadata from the catalog. There's a new DL1 call introduced with version 12, GUR. You run a GUR with the right key and you get XML data that describes your database. And from there, you can then say, oh, I know that bytes 1 to 10 are the key, bytes 20 to 40 are the address line, and all that stuff that you need to be able to describe a database in SQL. With the catalog, if the database DVD changes, the catalog gets an update. So and especially with managed ACBs, that can all be tied nicely into your change management system. So the DL1 model utility is gone. There's no more Java files, although if you had old-fashioned Java files, they are still supported and they still work. And in theory, you could code one by hand. I looked at doing that and decided I wasn't even going to go there. So we can run GUR ourselves. We can do it in COBOL. We can do it with Diddleto, the test program. You get XML, but the XML, even on the mainframe, comes back as ASCII, which is a pain. Because it's XML, you need a data template definition, and those are supplied to us in the samplib. So we've got one for the DVD and one for the PSB, and that describes what's in the catalog database. So first thing we need for catalog and ODBM and IMS Connect and external things doing strange calls against our database is the commit manager has to be RRS. So everybody has to run RRSY. So that's, I think, as far as I could see, that's the only startup palm in IMS that changes, is we go RRSY. Because the catalog's OSAM, if we don't have OSAM today, we do have it tomorrow. So we may need some OSAM buffers. And because it's OSAM, you get to choose the block size. You're not fixed to the standard 4K, 8K, 12K, 18K block sizes like VSAM. So we can pick a buffer size. We can make the catalog is a HowDB. It is standard IMS OSAM. You can run standard DL1 calls against your catalog. It just works exactly like any other OSAM database, including DBRC registration, the whole shooting match. CG, that's the IMS Plex Proclib updates. For my system that I was playing on, I added RMenv equals Y, and I added a resource manager. And that's because I've got the title wrong on this slide. That's the resource manager JCL, because I was changing an IMS system that I was working on from being just a standalone IMS with resource definition data sets into one with the full scale repo and the catalog and ODBM alongside the IMS Connect that was already there. I'll change that title before I publish the slides. So with the RM, it's got a reference to the repo, because that's what the RM and the repo are joined together. And then we've got the repo JCL, which is here. That's going to actually run the repo with its parameters, which are on the next page. So this gives us the vSAM data sets that belong to the IMS repository, and that's used to hold transaction manager definitions. The catalog holds database definitions. The repository holds the transaction manager definitions. It's a bit like DB2, where you have a catalog which holds the metadata and a directory which holds the control information for how to access the metadata. It's the same concept, except with IMS, we've split between DBDC, the database pieces, and the DC pieces. I'm still going to call it DC. I know it's TM. So we already had a DFS DF member because we had dynamic resources. So we've taken the resource definition data sets out and we've added in the catalog section. And because I'm going the whole hog with repository, I've added in a repository section, which is exactly one line of stuff. It's not difficult to define a repository to IMS. You do that, and then the way I did this, I cold started the IMS once I'd made all the changes I was going to make to IMS Proclib members. That was just because I was going to do a cold start anyway. You'd need to check in the books which pieces you can change on a warm start, but I guess most of you probably keep your IMSs alive most of the time, and therefore doing it on a scheduled cold start is a reasonable option. So once we've got the catalog OSAM database, and if you need JCL and stuff to create the catalog OSAM database, that is in the IVP. Build the IVP, grab the JCL out of the IVP, and you don't have to think about how to define database data sets. And then you've got to run the catalog populate utility, which effectively reads the ACB lib and inserts a record for every DVD and every PSB in the catalog. It's a great piece of JCL. It's desperately complicated, and we're counting commas because there's no easy way to put that string of stuff into the JCL without counting the commas. Unless we start using ZOS system symbols and all that gubbins that we can do in JCL these days. Normally what I would do on a first catalog update is run that offline. Then I'll image copy the catalog database because it's DBRC registered and we want it recoverable. Then I'll get it online. So once it's online, I'll DBR it and start it with access equals UP, because I want to be able to update the catalog database with a BMP. I've never run the catalog populate utility as a BMP because I don't think there's any value in doing that. I much prefer to run it as a DLI batch job. So here's a piece of JCL for the utility. Oh, there I've got it running as a BMP. Oh no, sorry, this isn't the catalog populate utility. This is the ACB gen, the catalog ACB gen changes. So sorry, the title of this slide's wrong. I'll fix that as well. We're running DFS 3 UACB. That replaces running DFS RRC 000 palm equals UPB. So the first half of the JCL on the left-hand side of this page looks exactly like regular standard ACB gen. It's just exactly like you know today, except we've got some extra DD statements which point back to the ACB lib. We've got some catalog work temporary data set, and then we've got the parameter for the populate utility, which will read the ACB lib. So we've built DFS IVP 33, and it will insert a new record in the catalog database for that database that's just been ACB gen'd. Sorry, that PSB that's just been ACB gen'd. And any databases that get pulled in if they're not already in the ACB lib and not already in the catalog. So this gives us the first of the problems, right? Everybody has their ACBs built on their development system and then shipped out to their production system. And they're done with things like SCLM if you're crazy, or Endeavour if you're the rest of the world, or Ziggy if you're into this new Git stuff. Henry Kuiper does a good presentation on Ziggy and how Ziggy could be possibly a replacement for things like SCLM. So here's the first problem, is that if we run ACB gen on development, we've got to somehow unload the catalog and reload it on the production system. So until managed ACBs, that would have been a regular IMS unload. For a reorg, you'd have to keep the catalog on development the same size, same shape, same parameters as your production one. And every time you want to move something, you've got to somehow unload the segments from where it's been ACB gen'd and insert those in the production catalog database. So clearly, whatever we do here, the guys who are in charge of change management and program promotion and all of that stuff are going to have to work with the IMS people. They won't like it because they've never heard of IMS and they don't know what all those funny little processes in Endeavour do, but you're going to come along and have to change them, which means we've got to understand how this stuff works. The other thing is we're not going to run the catalog populate every day. We're going to run an ACB gen running the new ACB gen process. That could be that you build DBD lib and PSB lib in development and run ACB gen and catalog update in production. That's your choice. With version 15.1 and 15.2 and managed ACBs, they've given us some extra pieces. They've given us a catalog export, a catalog import, and the library builder, which are basically the old library management utilities repurposed to work for catalog. So we can now do more with pulling stuff out of the catalog and putting it from one catalog into another. It's a bit like the DBRC partition definition utility for partition databases for HowDBs. Those pieces have been there. Those last three utilities I've not played with because I don't have managed ACB. So the next thing that we're doing, once we've got the catalog, we've got to find some reasons or ways to exploit it. So with ODBM, we can now push the stuff out to the small systems, to the the Linux systems, the Windows servers, what have you, or even DB2 stored procedures with the Open Database Manager. This lets us run DL1 calls without being directly connected to an IMS system. The ODBM looks to IMS like a database resource adapter, which is how KICS connects to IMS. We connect to the ODBM, we say, go and schedule that PSB for us, run this DL1 call, give me the results back, and when I've finished, deschedule the PSB. So it is very similar to the process used for an exec DLI program. You can use it in DB2 stored proc, so that gives us DL1 from a stored proc. And it is used by Connect. Excuse me, I'm just going to have a drink of the coffee. So it is used for remote connectors. That's Java DL1, JDBC, and if you're crazy, you can do a DRDA native client. Of all protocols, for all things in all the world, DRDA is my favorite. It's about 1,500 pages of reading to learn the protocol, but it's super easy to use, it's super easy to debug, and it gives you complete control of your database. So ODBM is another new started task in IMS. It's another one that's running under BPE, and it's, you know, we've got CSSLib because we're playing with RRSY. So it is an RRS client. It's got its own startup palm, which basically says, this is what we are, this is why we're here, this is how we identify to the IMS system. So most interesting one there is the diag dpsv message equals long. So that's to avoid an event 210. It gives us lots and lots of happy, friendly messages when things go wrong in ODBM. So on your development system, you want that setting. On production, you may want a different setting. So to define a client to use the ODBM, we're running the DFS PRP macro, which is how you build a KICS connection. And on the tail end of that macro, we add 2 extra parameters. One to describe the IMS plex, and the other to describe the ODBM name, which you can probably guess my IMS ID is IT2A on this system. Right, so once we've got ODBM running, we can connect ODBM to IMS Connect. So IMS Connect can now act as a TCP/IP gateway for ODBM, which is the Open Database Manager, which is the way to get DL1 into IMS from an outside system. So we've already got the stuff at the top, the transaction processing, you know, good old fashioned, send in an IRM, send in a transaction behind it, run the transaction, send the answers back. We may have the MSC links, we may have the ISC links if we're in the land of TCP/IP networking rather than VTAM. We may be doing call out, and if we've got the is it IMS Command Center or whatever it's called, we may have command processing going through Connect. So we've got 4 components we're going to add: ODBM, Java, DRDA, and JDBC. And that's easy. It's 4 lines in your IMS Connect proclib member, plus we're also setting RRSY. So here we've got a port number, which is what we're going to use for the TCP/IP connectors. we've got a description of the IMS Plex and the a name for our connection. And we're saying, as you start up first thing in the morning, if ODBM's available, connect to him. If ODBM comes up second, connect to him. So the connection's going to always be alive. So if we talk to that port, we can send strange stuff into IMS, which will do strange DL1 calls and send the answers back. So next thing we have to do, and this is before we install the DVDs in the catalog, is we've got to give them some names that are going to be used in SQL. There's a good example, DFS IVD2, which has the new parameters in the DVD. And you give it just an external name, and the seg-m name is the table name, the field name is the column within that table. So that gives us phonebook.firstname as a fully qualified name for the F name field. PSB changes. We want to run AC with AIB enabled PCBs. So we need to make them have a PCB name. IBM messes us about because the one I picked to use, I had to reassemble the PSB because IBM doesn't give us a PCB name. So I've now got a PCB name of PCB01, which allows me to do an AIB call to access data in the A11 segment in the IVP DB2 database. Proc and key length and all that stuff works exactly as normal. And this one's got a modify equals yes, so it can do other DC stuff. So Java programming, when it comes to Java programming, we've got Java JDBC or Java DL1. So JDBC works the same way as it does for DB2, for Postgres, for MySQL, for SQLite, anything. You name an SQL database that has JDBC, and it's all much of a muchness. It's a quite an elegant little programming language. It's an extension to good old-fashioned Java, which is quite an elegant programming language. Java DL1, we're doing get unique, get next, get hold unique, insert, replace, delete. Standard old-fashioned regular DL1 calls. I've given you a link there for the Java programming reference so that we can see everything that's in imsudb.jar. Once it comes into IMS, it looks like a standard DL1 call, which means we can trace what it's doing with the compare trace. The compare trace can give you some good clues when you're getting strange status codes. If you get an SSA wrong, you get an AC status code or an AM status code. You will find that in a compare trace. And that's one way that debugging these things can become easier. JDBC, look, it's easy, it's familiar, it's exactly what the kids in university are being taught today. The SQL language has some dialects. So MySQL SQL and Postgres SQL and DB2 SQL kind of look like SQL, but they've all got their little quirks about them. There's things that DB2 doesn't do that Postgres can. There's things that IMS doesn't do that DB2 can do. So you've got some language differences. It's like being whether you're a Brummie or a Geordie or a Londoner. So it depends whether you speak Cockney or Brummie or Geordie. That's the kind of level of difference. It all looks the same. It all sounds the same. You can probably understand what someone's telling you, but the subtle little differences. So you read the books about things which exist in one DB2 dialect that don't exist in another. So ultimately, you fire in SQL, IMS turns it into a DIL1 call. The DIL1 call returns the data, and IMS hands it back as a result set. So when we paint SQL across a hierarchical database, each segment looks like a table. And each dependent segment looks like an SQL table with a foreign key. JDBC and IMS, you've got type 2, which is running JDBC within ZOS, or type 4 remote, which is what we're more likely than not to use through IMS Connect. And type 4 just makes more sense. In fact, I use type 4 everywhere. So here's a bit of Java. So we're going to connect to a host name, and I've blanked out the IP address because it's irrelevant here. It's your system. The only piece that's exciting here is the port number, because that matches the port number that we've defined in IMS Connect's ODBA statements. We say create a connection, use a type 4 driver, and here's all those funky parameters that you need to get the connection going. That will create a TCP/IP connection from your remote system to the IMS Connect system, and IMS Connect will go through ODBM to schedule the PSB DFS IVP 33 in this case. And at that point of making the connection, it accesses the catalog database and pulls the metadata back down to the client. So the database metadata is always current because it's the act of making the connection. That ds.get connection call at the bottom of the page fetches the metadata. Then we can start doing SQL. Look, there's a massive big lump of SQL in the top of that page. So that's create a statement, execute the statement, get a result set. Once you've got the result set, go and fetch each row that's in the result set till you're done. That's what that piece of Java's doing. So in this case, we're selecting those external names that are in the DBD from the PCB name that's in the PSB and from the segment name that's in the DBD. So phone book is the segment name, last name, first name, extension, zip code are the field names, and tele PCB is the PCB name in the PSB. Very simple, create a statement, execute a statement, fetch the results. That is standard JDBC. That works everywhere. The only thing that makes it IMS is the definition of the connection, which we've done on the previous page. So this connection is an IMS connection. This piece of SQL would work against any connection as long as the field names match. Sorry, column names. DIL1. DIL1's much more exciting because we love DIL1. Some of us have been writing more DIL1 in the last 5 years than they had done in the previous 40. I'm writing it in COBOL. I'm doing DIL1 in COBOL. I'm doing exec DIL1 in COBOL because I hate exec DIL1. But for DIL1 programming, you need to know what the hierarchy of the database looks like. When it's JDBC, the hierarchy is mapped to tables with foreign keys. When it's DIL1, it's get the root, get the child, get the grandchild. And segment search arguments are in here. It's just standard, good old-fashioned DIL1 programming. Excuse me. So there are some IMS system services POP calls that we can issue, but I've got no examples of doing that. I always use an AIB because it's easier. So again, we make a connection, except this time on the connection, we build a PSB factory. So the PSB factory is a special Java class which handles accessing it as DL1 rather than SQL. So once we've got a PSB factory, everything else on that page is identical to creating a JDBC connection, even down at the driver type 4. It's the PSB factory that makes it different. So once we've got the PSB, we have to tell it which AIB name we want to connect to. And now we're talking about segments and fields. So the segment name here is a phone book. The fields are qualified as last name equals Baggins. Oh, sorry. So we've got, it looks a bit like running DL1 in COBOL, except the SSA is built slightly differently. But fundamentally, it's a map to a good old-fashioned SSA, complete if we just take the parentheses out of it. When you build an SSA list, add initial qualification, it builds a standard IMS SSA string. Then we're going on this one, we're going get unique. And then we pull one segment out and systemout.printf it just to print it out. And I've got all those funky formatting to make it look nice and neat. Then we commit the PSB, close it, and we're done. This was an interesting wrinkle I found because I did all of this writing Java back in March. And then literally about 10 days before lockdown, I bought this happy, friendly, nice new HP laptop that replaced my old laptop. So it's got a much more modern version of Java on it. It's got Windows 10 and the very latest Java. And I was getting no class-defined found error. So I opened a ticket with IBM and they gave me some strange stuff to add to my Eclipse project to get it working. So I've left that on a GitHub. There's more about this GitHub later. And that was just one little wrinkle that I found in playing with this stuff, because I've done it in March. I came back to it in October. Next one we're going to talk about is COBOL. And this COBOL is, I think it was version 13 that the SQL IMS piece came in. And it's basically SQL against an IMS database, but on ZOS on the mainframe. So we need an SQL CA, we need an SQL DA, we need an SQL statement, and we need to run it as dynamic. So everything for IMS is exec SQL IMS. That's to distinguish it from exec SQL, which means DB2. So that you could, in theory, have an IMS program running DB2 SQL and IMS SQL at the same time. But I have not tried that. So what we do is it's dynamic SQL. So if we've done DB2 programming, it's the same basic principles. So you declare a cursor, you build an SQL statement, you prepare the statement, you describe it, and then you run it, and it gives you back an SQL CA. And in the SQL CA, you've got SQL code and SQL state. The only thing I found was, because I'm a rubbish COBOL programmer, is I kept getting 5000J rather than minus 5001. So I did a little bit of COBOL jiggly pokery to get it to unpack the packed decimal field properly. Kix with ODBM, nothing changes. As far as I can see at the moment, Kix is not going to want to use ODBM. But my testing may have not been good enough. And as I said, the theory is you can do Java DL1 and Java JDBC, but I'm not going there. You know, we'll cross that bridge when some crazy person comes up with it. Oh, we're running DL1 in Java from Kix. Oh, good. Thank you very much. Yeah, let's have an investigation of that thing. Next thing we're going to talk about is batch programs with ODBM. So we can run effectively a ZOS batch program that runs good old-fashioned DL1, but doesn't run under the IMS region controller. So it's no longer running as IMS batch or DLI batch, and it's not running DFS RRC00 as its JCL program. It runs program equals frog. And the frog program that I've written does an AERTDLI call rather than an AIBTDLI. All calls use AIB, but as I said, all my calls use AIB unless I'm being crazy. Because AIB came in with, I think, IMS version 3.1, so we should be using it by now. Best thing with an AERTDLI program is you can't get a 113. You can append the program and IMS goes, oh dear, my DRA thread that's coming in through ODBM has just died. I will clean up nicely and keep you alive. So that's one of the benefits of it. So it's AIB, but we're just running some extra calls. So we call AERTDLI using a connect IMS call. And you give it an initialization subfunction. You tell it what ODBM to connect to, and that's used to find the PZP module. So you've got a module in your IMS ResLib called DFS IT2A0, and that gives you a resource name of IT2A. Once you run the call, you get standard AIB return code, standard AIB reason code, and you've got standard AIB resource names. So you test for return code 0, if it's non-zero and it's 2304, that's hex 900. Then you look at the PCB for the status code. Anything that's not 0 or 23, take an append and look at it to find out what's gone wrong. So we can move resource names, we can run a PSB, which is allocate PSB call. That's just like the schedule call in Kix in execDLI. We can run get unique, and then we're off and running. And you know, once we've done the first get unique, it's standard DL1 from there. The benefit with AERTDLI is you can run that in a stored procedure. So the stored procedure in DB2 will connect to the ODBM. The ODBM connects to the IMS, and you can run DL1, standard, good old-fashioned get unique, get next, insert, replace, delete calls in a stored proc. There's some pieces you have to do, especially for DB2 stored procedures, because you may want to connect to the IMS once and leave the connection alive for the next time that stored procedure is scheduled, which is why we've got a terminate thread. So we can do terminate, destroy this DB thread, or terminate all, terminate all IMS DLI ODBM threads in this stored procedure and let the environment go back to as if it's never been near IMS before. But other than that, it's just the same stuff that we're doing here in the batch program. Once again, if we bend in the stored procedure, DB2 will go, oh dear, my stored procedures are bended. I'll set the counter going for when I'm going to stop scheduling it. Workload manager will spot the bend and go, if that workload manager application environment bends many more times, I'm going to stop it. But IMS will carry on because ODBM sits in the middle and protects us from the 113. And that's it. That's where I'll get to the end of it. I don't know how I'm doing for time. Oh, over time, sorry. We'll talk about managed ACBs in a future presentation. And there we go. I've got some adverts and stuff at the back of the presentation. I've put all my samples at this URL on GitHub. So, and I updated that this morning with the extra pieces I needed for that JDBC failure. So questions. I think Dominic needs to open it up for questions now.
Yeah, I've just opened it up, so I've asked everybody to unmute if they'd like to enter the discussion. So more than welcome. I mean, I've got a couple of questions just to kick off, if that's all right, Doug.
Yeah, sure.
Firstly, I mean, I think you were saying about early on in the foils, you were talking about the creating the catalog and, you know, obviously the data sets for that. And I know that certainly in our environment, we've got a lot of skewed data for PSB names, that kind of thing, and database names. So have we got any considerations for the HALDB creation for those, you know, in terms of doing partitions, that kind of thing, in terms of importing, you know, the ACBs, PSBs that you've actually got in your shops?
Yeah, you've got 30,000 ACB members. So you're going to end up with 30,000 segments in your ODBM, sorry, in your catalog database. It's OSAM. It can have 1,001 partitions of 4 gigabytes or 8 gigabytes, depending which flavor you want to go with. That should be enough to hold one segment per ACB lib member, because that's what you get. Effectively, every member in the ACB lib produces one root segment in the catalog database. All of the pieces below the actual ACB are segments, fields, sensegs, send fields, and all that stuff that's in your DBD or your PSB. But in general, you've got one root for one ACB lib member. Until you start updating, because then you can have more than one root. If you do an ACB gen, you can leave the old member in the catalog database and effectively have 2 versioned members in there. And IMS knows from the ACB timestamps which record from the catalog he actually wants. And because it's an OSAM HALDB, you know, you can partition it how you like. It's got four dataset groups and 1 primary index. So you can even have different numbers of partitions for the catalog database and for the catalog's index. It's standard. It just runs standard OSAM. So hopefully it's not a problem to you. I think the bigger problem is the development to production migration pieces. And that's the piece that scares me, because I will never have a chance to to understand how that piece works.
Sure. Yeah, and I guess with versions, I mean, as far as I know, we can decide how many versions that we have.
Yeah. And,
yeah.
and if I was you as Barclays, I would be looking at going the whole managed ACBs layer. So not just the catalog, but do away with the ACB lib. So you no longer have ACB lib A, ACB lib B. Everything's held in the catalog, and the ACBs are built in IMS from the catalog. And that's that, as I said, that's a presentation for another day, for another year. And partly because I don't have a system that's capable of doing that yet.
Yeah, sure. I mean, yes, we've got the catalogue on our development system, but we haven't used sort of with managed ACBs yet. And
yeah, I think that managed ACBs,
we will be doing that.
I think it's a piece that IBM have designed with folks of your size in mind. Mm. And the idea is the whole reason for doing this stuff is for DevOps, so that the developers can be much more in control of how the operations of their system works. You know, that's what managed ACBs is for. You can see it's for containers and DevOps and all that funky new stuff, which we don't do in traditional old-fashioned land of IMS, for those of us with a grey beard.
Okay, thanks for that. And I've got another question, but I'm just conscious of time. I know we've got about 10 minutes left, so that's fine. I've just got one other question that I was thinking of, and I'll try to get some others to respond as well. But another question from me was to do with, you know, the ODBM to IMS Connect layer. I mean, what is the performance like? Is that something that people have got in their shop, and what is the performance like in terms of number
my experience of it is running about 6 SQL calls in a row. Because that's what I was doing. I was doing it for functionality, not for actual performance and use. So I honestly can't answer that question, but I would have thought that someone like Steve Nathan would be a good person to approach and ask whether IBM have got any performance figures for it. It's either going to be Steve Nathan or Deepak. And that's a good question, is how scalable is this thing? Because we know that IMS Connect had to do an awful lot of work to become scalable for transactions in through Connect. But now we're sending DL1 or JDBC in through Connect. Yeah, so scalability becomes an interesting question.
Yeah.
And so even since we know him well, even Kev Stewart. So Kev Stewart, Deepak, or Steve Nathan is who I'd approach for it.
Excellent, thank you very much. So we can open up the questions for anybody else. All right, okay. So some people are asking for unmuting, so I'll get to unmute all again. But has anybody else got any other questions? If please go ahead. I've asked everybody to unmute, so if anyone's got any issues with muting,
I'll do the adverts now. I was told to put this page in by the powers that be at BMC, despite the fact that I don't work for BMC, because I'm a fly-by-night contractor. And then the better foil is this one, the GSE UK Conference Charity. Put your hands in your pockets, pull some money out, give it to the charity.
Sure.
Hang on, I sounded like Bob Geldorf then.
Yeah, and the other thing you said in a previous foil is the feedback. We do value your feedback on any of the sessions that we've got. And just to confirm a bit more, we've got a couple more sessions on the IMS stream to go. So if you still haven't had enough of your IMS sessions, there are 2 coming up today one on IMS performance and another one on IMS administration. So please, all, if you're available for those sessions, just have a look at the agenda items. One's at 1 o'clock and the other one's at, let me think what the time is of the other one. I'll just get that. Yeah, one from 12 till 1 and one from 1 till 1:30 till 2:30. So we've got
have a question.
Right.
Laura's got a question.
Yeah, hi, it's Aurora. I just wanted to say thanks, Dougie. That was a great presentation, very useful to
Thanks,
my
Laura. Thanks for that.
Nice
a while since we've met.
Razor, and I'm glad you quoted Bob Geldof instead of tax evading Bono.
Oh, right, yeah, yeah. Bob Geldof, I remember it when he stood up on the stage in 1985.
Yeah.
Put your hands in your pockets, get your money out.
Yeah, exactly.
So does Kieran have a question? Because he says
I do. Can you hear me?
Yeah,
yes,
can hear you. Thanks,
yeah.
mate.
So my question is, obviously, it looks like IMS seems to support SQL reasonably well now. Meanwhile, the rest of the world is going back towards kind of no SQL databases and JSON access. Do you think there's any room for IMS to support JSON directly rather than through
COBOL does.
Sort of thing?
COBOL has JSON, and IMS is the original NoSQL database. Just remind people of that. Back in 1967, we had no SQL. So tell them to stop trying to invent new things when we've had old things forever. Yeah?
Yeah.
IMS is the original NoSQL, and I will continue to tell people that. But yeah, COBOL 6.2 has some JSON, and 6.3 has some JSON support.
Okay.
Despite the fact that we hate JSON because it's horrible. No, I've been playing with JSON because I now am pulling data off my car charger and data off Octopus Agile's electricity tariff, and that all comes back in JSON.
Yeah, because my thought is that obviously we've got ZOS Connect now that can connect through and access the programs via JSON. But if we could get direct access JSON into the database,
well, this is another thing that we need to talk about is at some point ZOS Connect, because whether it can do that stuff for you by effectively doing some voodoo in ZOS Connect that then becomes DRDA to IMS Connect and then gets your data from DL1, that may be a route to get JSON out of IMS. But I've not ever looked at ZOS Connect because I haven't been interested enough.
Fair enough.
And none of the people I've been working for have been interested enough either.
I mean, certainly, but we've got, we've got API stuff now where we're doing ZOS Connect to IMS Connect, and then into IMS. We've got a few applications exploiting that at the moment, which is quite good. But yeah, it's a good point, I think, Kieran, regarding the direct access from JSON. So.
Well, there you go, Dominic. There's a subject you may need to find someone to talk about it for GSE 2021.
Absolutely, yeah.
It's probably a reasonably good idea to talk about IMS and ZOS Connect and JSON and all this DevOps stuff, and actually have someone do a specific presentation on it.
Yeah, definitely.
That gives us an idea for next year. Although hopefully next year we'll be at the Celtic Manor. Because part of GSE was always getting lots of alcohol down your neck.
You just get your own coffees that you have to provide now. Okay, so have we got any more questions? Any more burning questions? There's about a minute left, I'd say. No, that's fine. So thank you very much indeed. Again, thank you. Give a round of applause. Virtual round of applause for Dougie there. Great presentation, and we look forward to you joining the other two sessions we have on today. One for IMS performance and the other one for IMS administration. and that would be the close of the IMS sessions for this year.
Yeah,
But,
you could
thank
ask
all
your
for joining, and have a
you
good
could-
rest of the day.
Dominic. You could ask your DRDA performance question for the performance guy.
Yes, we could. Will
just
do.
to be evil.
Yeah. Thanks very much, all.
Thanks,
Bye.
Dominic. Talk to you soon.
Appreciated. Bye.